Okay, so tell me this. This is let's see. This is what, a sequence or series? Is a
sequence?
very good, right?
Okay, but what's the difference?
I'll tell you, this is sequence, right?
Okay.
Okay, so this is like 1/1/2, right? Makes sense? 1/3, right?
Okay.
Etc. etc. Does it converge? Okay, does it converge? Yes or no?
Yes.
Okay, yes, it converges to 0. Yes, okay. Now, let's see. If I do this, if I start adding these terms, see this here? Converges, we just said converges, yes, right? Okay. Now, if instead I was adding all the terms,
Does that
okay?
make sense? I don't want to answer for you.
Okay.
Does that make sense that it converges to 0?
Yeah, because
Okay.
denominator gets larger.
Right, right. Thank you. And if any of you has any objection on any of them, speak for yourself, all right? Okay? Because we don't have any Windows Vista problem of sound
Right.
disappearing, right? No? Cool. Now, that is convergent. Now, who is this? This is a series. Okay?
Okay, why? Because we're adding?
We are adding, so we call it a series.
Okay.
When the terms of the sequence are added up, it's called a series. And it's infinite series because going forever, right?
Okay.
Am I clear? Good. Question. So the thing is, and there is a shorter way of denoting it. Go from n equals 1 to what? Infinity. You're familiar with summation notation from calculus 1. We did Riemann sums, right? Remember that?
Yeah.
Okay. So this is what? This is the same thing, right? See that here? Like this, going forever, right?
Okay, so let me just recall. So this, it means that you are actually adding them.
Exactly.
Okay.
It's capital letter sigma. So Greek capital letter sigma means sum it up, right? Okay, it's going to go on YouTube. I don't know Greek, I confess. So but it's for amongst us. If somebody's watching it, they watch it at their own risk, right? Okay, good. Now the thing is, this is like 1/2 here, 1/3 here, etc., etc. Right?
Yeah.
So we want to answer the question if it converges. Converges means if we go on adding and adding and adding, you can see these terms are diminishing, right? One by one by one. Would it really get to a finite sum, right? Isn't that what a question is? Right? If it does, or if we can do that, we'll call it a convergent series.
Okay.
If we cannot, then we'll say the series is not a convergent series. Fair enough? Okay. So before I go on to this one, let me take something little simpler. And this is also simple enough. That might may look more complicated to you. Say I got this. Say 1 over 2 to the power n. Expand this for me, please. Who's the first term? If I put n equals 1, what do I get? 1 over 2, right? Am I clear?
Yeah.
Second term is 1 over 2 square, right?
So that's 1 over 4.
Very good, 1 over 4, right? So we got the right, and then we got what? 1 over 2 to the power?
8, 1 over 8.
1 over 8. Very good, Sam. Very nice, sir. Okay? Makes sense?
Yeah.
So, now we have to see if it really goes somewhere, right? Here. we got this. So what is it? It's like this, right? Say I added, so I added first 3 terms, I got that, right? I'm adding the first what? 4 terms now, okay? See this here? I get that, right?
Okay.
Let's add the first what? 5 terms, okay? 1 over 2 to the power what?
5.
5, right? I get that, right?
Okay.
Makes sense?
Yeah.
Now, if I want to add 50 terms, it'll be just 2 too much, right? Am I clear? So I'll do this. I can write it like 50 here, right? That's what? That's this, right? If I want to add, say, for 100 terms, okay, see this here? What will I have? 100. So we get, it says 1. It's not exactly 1, it says 1 to the level I can handle it, all right?
Right.
Am I clear? Okay, like say here is 90, let's say 90, let's see where it really gives up, it still gives up, right? Okay, so it's not exactly 1.
It's not really 1, right?
It approaches 1.
Okay.
Yeah. I mean,
Right,
the thing says 1.
Yeah, so approaches
That's
1,
the
yeah.
limitation of the
Yeah,
math.
it's a limit.
It's not limitation of the math, limitation of the computer.
That's what I was going to say,
No,
the math
right.
program.
It's a limit.
A math program. I'm
Yeah.
sorry, I didn't hear you and interrupted. Sorry. You gave me sound and I'm being ungrateful. Right? All right? Okay.
Okay.
Thank you, Kathy. You're so kind. Okay. All right. Good.
So how do we find that on the calculator?
Okay,
Or
calculator.
we're
We
gonna
show.
get to that?
No, I'm going to show that to you. It's very easy. Calculator. Okay. Now do this. Just give me a moment. Let me first do it. I'll replay it for many times because what happens is when we're doing this like this, then we get, okay?
Okay.
So here. Okay. So, right here. And this is my favorite way. Well, I'll show you 2 ways. So when we are doing a series, what we are doing? We are adding a sequence, right? So the way this calculator works on this is, it goes by what is called sum sequence.
Okay.
Am I clear? Sum
Yeah.
sequence, okay? So, you can look for some sequence in the catalog, okay? But I'm going to do this. There's a shorter way. Sam, you see? You're breaking the contract. Look here, he just wanted, so watch here.
Okay.
So if we did this, went to list, all right? Go to options,
Okay.
all right?
Can you see?
Yeah.
You can see?
When you go to options, it will map.
Right.
Some sequence.
Sum is right here, right?
Okay.
And this is going to be on the video too, I think.
Right, exactly, ma'am. Okay?
Yeah.
So
I was gonna go though.
wait a second. Sum, right? I know, we know, you know, right?
Right.
Okay, you know, we know. You know I meant. Okay, then this is sequence, right?
Okay.
And what my sequence is? 2 to the power, right? Negative n. 1 over 2 to the n. You know, it's 2 to the
Right.
power, negative n, right?
Okay.
Then it doesn't take n, so I'm taking it as like x, right? And let's go from 1 to, let's go 50. I hope it doesn't overheat.
What's the
Some of
second
that thing
x
does that.
for?
Oh, this one is 2 to the negative x.
Okay.
Second x says that I'm going according to n. All right?
Okay.
See this here?
Yeah.
Now this guy couldn't handle up to 50, right? See, it
Yeah.
made that equal to 1, no problem. Let's see, but you know this, let's see, oh, come on. What do I do? Second, enter, right? Okay. Yeah, let's see what it says for the first, for instance, 20 terms, right? Yeah, right. This
Okay.
makes sense?
Yeah.
Now, generally what happens is this, say if you have an expression which is like, more involving, you can do this, you can enter it here for y, right? And when you go to some sequence, right, this thing y, vars, then y vars, right? You can pull it up from there. We'll do an example like that in a moment, okay? Everybody good? Both of us, all of us good? Very good. So it approaches 1. Let's see what this guy does. Okay. Okay. So let's try it for first 10 terms. Okay. So that's right. Okay. So then let's try like 20 terms. Okay. Well, it's not stabilizing as well as that one did, right? Okay. So let's do like 30 terms. Right? Well, it's 3.99. Okay, who you never know, it might get to 4, right? Okay, and I'm not even thinking because the machine is working, so why should I think, right? Went over 4, right? Am I clear? Okay, so let's do this. Well, let's go to 100 for instance. Okay, are we good? Right? Okay, let's do this then. $200. Right? I don't know. It's not like not like leaping up, very fast, right? But we have seen the curves that increase, right, and even diverge, right?
Right.
Which don't. So thing is, let's think about it. Now remember, if you don't remember, it's okay. All right. So here, do you remember this integral? 1 to infinity 1 over x dx. Do you remember that?
Yeah.
It's called what? It's called an improper integral, right? Are we good?
Okay.
Okay, yes, very good. Thanks, Kathy. Thanks for taking it that way, okay? It's an improper integral, right? Why? Because I can't handle infinity as a quantity, so what do? I just go ahead and, follow like say limit alpha as alpha goes to infinity, because otherwise my calculations would look not that legal, right? So then we got this, right? Am I clear on this? I just said if this can be written as that, right?
Okay.
Okay. So I'm going to write this integral, right? And then take the limit. If that limit is available, very good. Then, first let's do one thing at a time, right? So this is what? This thing is this here, and where is the other thing? Okay, so here we go. I'm just writing ln x instead of absolute value because we are in positive territory, right? Are we clear here?
Yeah.
Okay, Kathy, are we good? The integral of 1 over x is natural log of x, right?
Oh, yeah, okay.
Okay, yeah, right now. I know it's been, okay, we will be flowing. Then minus natural log of what? 1. What's natural log of 1? Any log of 1. What is log of 1? Come on.
2.71.
Come on. We are on, it's being recorded. Okay, I'm nervous now.
I'm being recorded.
Natural log of 1 with any basis
0?
what? He's saying as if he knew it always. He did, right?
I know that this isn't the time, but I never really did understand.
Okay, let me just show you this, okay? I'll
Okay.
show you this, okay? Because we
Yeah.
are going, okay, see this here? Look here. If e to the u is v, right? Then what we have is the natural log of v is what? U. Are we okay on this?
Okay.
Sure.
No.
Exponential and natural log, they are inverse functions of each other.
Right, okay.
Okay.
So if e if exponential with an input of u gives you output of v, then natural log for input of v will give you output u.
Okay.
Are we happy here?
Yeah.
Very good. So, e to the 0 is what?
1.
1. You understand that, right?
Yeah, because everything to the power of 0 is 1.
Any non-zero to the power 0 is 1. Yeah, everything will include 0, but 0 to the 0 is indeterminate, remember?
Yeah.
So, go by, who is this? V is 1, right? Am I clear? Who is u?
0.
Do we understand it now?
Yeah,
Yeah,
I mean,
this
I
is-
understand that that is the way that it is, but I don't understand
that
what
is-
is meant by natural log.
What is meant by natural log?
Yeah,
Natural log is a function.
okay.
What is meant by natural exponential function? That's also a function which models many things. One of them is natural growth. Okay? For example, say if you let something grow freely in an environment, then it generally grows according to the amount of that particular thing being present, whether it's bacteria, whether it's people, whether it's birds, or whatever, right?
So it's just the shape of the function, it's not real number.
Good. So are we good here? Good. So if I am looking at this, then, all right, if I'm looking at this, then what is this? Limit as,
You started recording.
yeah, I started recording, yes. So yeah, don't get upset with me, otherwise it will not look good, okay? ln alpha, right? And what is that? You saw the shape of natural log as alpha goes to infinity. This will go to what?
0.
Infinity.
Infinity.
Oh, as alpha goes to infinity, okay.
Exactly. If it was e to the negative alpha, it will go to 0, right?
Okay.
Makes sense?
Alright.
Which means what? Which means the following, that if I try, say, approximating this area, say from, say, 1 to, see this here? Let me just adjust the window. Okay. So if I try doing that, right, then this area does what? Eventually this and this, they become like, not like parallel, and this whole area will be how much in value? Infinite, right? That is it. Or in other words, let me know.
Because it never
Infinity, yeah.
touches 0, so.
Right.
Sometimes it may not touch 0, but still it may get to a finite value. For instance, let's do another example. Okay, let's do another example. Yeah, because see, would this ever touch 0? You compute this for me on the same pattern, please. Yeah, here I'm giving you another question. 1 to infinity. 1 over x square dx, right? Could you guys do it quickly for me, please? Okay, just do it quickly. And
1.
very good. Okay, so what is this again? Along the same lines. Okay, along the same lines it is. Kathy, pay attention. Okay, and stop me right away. Okay, and unless you guys approve it, I won't put it on YouTube or anywhere. Don't worry about it. Okay. Yeah. So here we go. See that here? Makes sense? So this is, now what happens is this, we are recalling this portion here, that x to the n dx is what? X to the
Plus 1.
n
over
plus 1 over,
n
plus
plus 1.
1, as long as n is not negative 1. If n is negative 1, it's 1 over x, and what do we write? We write it like, what? Natural, it becomes natural.
LNX.
Very good. Thank you, Kathy. Very nice, very nice. Okay, so this becomes what? Good. We are having having a good day. Good. So here, so if I went like that, right, then what happens? It will be along, see, it's x to the negative 2, right? Okay, so that will be going in Sam's style, negative 2 plus 1 over negative 2 plus 1, right? And then it is alpha here, and what downstairs? Help, quick, quick, quick. 1, right? Makes sense? Okay, which will be what? Which is going to be, let me write it down here again. Okay, so that's x to the what? Negative 1 over who? Negative 1, right?
Why did we switch from n to alpha?
I didn't write all. Oh, here?
Yeah.
You can write n, I have no problem. If you want, I can write n.
No, I don't need you to. I just.
It's just like I needed a symbol here
Okay.
to be able to.
But it's the same thing. It just means any whole number.
It's not any, it's any number in this case, and if I am doing the summation like a series, there it will be a whole number, okay? But here I'm looking at a continuous variable, right?
Okay.
So alpha could be any number, right?
Okay.
Good, very good, thank you. So here we go. So we got what? Okay, we got this, okay? And I'm going slow, no problem. You will be fast later, right? Okay, so this thing is what then? Simply negative what? 1 over, what's that? X, right?
1 over x.
1 over x, very good. See? So, in here, see this here? If I just put all the values in, or if I put the limit in, it'll be negative 1 over what? Alpha, right? Then minus, then negative what?
Big 1.
1, right? Are we good? Yeah.
No, that
No.
last part I didn't get.
Okay, see this here? I will substitute alpha first, that's what I get,
Okay.
right?
Yeah.
Minus, then I'm going to substitute 1, right? So 1 over 1 is 1. Then I have a negative sign, right? It's a negative sign.
Okay.
Okay?
Okay.
Making sense? Okay, see this here? Oh, I'll just substitute it the way it looks. I know it's late in the evening. We are all tired. Is that good?
What, you just wanted to put the first value?
See, first I put the top limit, right? Here.
Oh, okay. I see.
You say, I know you'll say it.
Right.
Oh, I see.
Okay,
The top
yes.
limit minus the bottom limit. Okay.
Very good. That's fantastic. Okay. So what do we get is this whole thing is 1, right?
Okay.
Okay, very good. And as alpha goes to 0, this guy goes where to? Sorry, as
To
alpha
infinity?
goes to infinity, this guy goes to 0, right? So I'll get 0 plus 1, that is 1, right?
Right.
Makes sense?
Yeah.
So this whole thing is going to be how much simply then? 1, right? So remember this, we said that because it never touches 0, let's compare it with the other one. See, in this case, look here. So this was our like 1 over x, right? If I put 1 over, if I add 1 over x square in here, right? So it goes on becoming smaller and smaller and it's not touching this, you know, it's an illusion that's touching, right? You all know, right? But it's still the area under this guy is converging, right? While the area between the x-axis and this black curve is not converging, right? Are we clear?
So it's not convergent?
This one is converging between the x-axis and the red curve, all right? And between the x-axis and the black curve is not converging because that
Because
was it.
it's only approaching 1.
And this one was approaching infinity, right?
I figure it like converts to 1.
this converged to 1, the area under the red curve, because this red curve is 1 over x squared, right?
Right.
That converged to 1, you're right. That means as I keep on, taking larger and larger values, it will get to 1, right?
Right.
Makes sense? But for this one, remember this, we just did this here a short while ago. This guy becomes infinity, right?
Right.
That means, and who was that one? The black curve, right?
Yeah.
So if I try to, if I keep on going and going, the area between the black curve and the x-axis will go on becoming larger and larger, right? Okay? But the red curve and the x-axis will converge to what? Eventually it will become very close to how much? 1, right?
Right.
Right?
Yeah.
Okay? So go outside or somewhere, because here it's going to get very claustrophobic very soon, because
Right.
in the evening and no window, nothing, and I just don't like it that way. Okay? Well, outside is nice, right? Okay, we'll go outside and sit, because Kathy got us the computer going, so we are good. And Sam, of course, you got us. You guys are great. Okay, so what were we doing? Okay, now remember there is a thing that you saw. It's called integral test. I'm not going to go over that right now. Okay. As a consequence of that, what you saw is, and keep this in mind, because it's a big thing, whenever you're doing series, so, people will expect you to have that infinity, then summation. Say I got this guy, okay? It's a series, right? And then, let me not say integral test, okay? I'm just saying because of these improper integrals, and I've posted the videos on integral test you can watch, lessons you can watch, but let's just get to the thing here. Is that good? I have a series like this, right?
What's P?
P is any real number. For example, if I took, say, P equals 1, then this series is what? Then this series simply is this, all right? Am I making sense? You change P, the series changes, right? If I took, say, P equals, say, I took 2, all right? Then this becomes what? That. Am I clear?
Yeah.
If I took, say, P equals 1 over 4, am I clear? Then this series becomes what?
1 over 4.
And to
That's
the
the 1 over 4.
thank you, Sam. 1 over 4. I did that, sir. Okay. Now, this series, it converges. Converges means what? The series that we saw in which the sum was getting closer and closer to 1, right? If and only if, let me just go through a shortcut for if and only if, okay? If and only if P is greater than 1, all right? Am I clear?
Initially, I thought if it was, initially I thought it was less than 1, but
Come on, Sam, we just saw that 1 over n. This is divergent, right?
right.
And 1 over x is convergent, right? Yeah, improper integrals are on the final, don't forget, okay? All right? Okay. Are we good here? So tell me, what about this? This converges or diverges? We just saw. What does it do? Help. P is what here? The power.
1 over n, it diverges.
It diverges, right? Okay. This is a very, okay. This is called even P series. What does this do?
Converges?
Converges. Good. Then, what does this do?
Diverges.
Diverges, right? Makes sense?
Yeah.
Good. Okay, so let me stop recording and